All right. So here we are back to Excel. And so this week, what you're going to do is you're going to find KA, but not one single KA. You're going to find for multiple points. All right. So first, just remember last time you collected data, pH data along the titration. And the first step is to then use the first derivative plot to tell us this volume of base that was added. All right. And this number should be very similar to what you got from last semester using the indicator because they should lie roughly in the same volume. So here it says that you're going to find the equivalence point for each plot. You're going to use what we call first derivative. And so here it's what it's showing then is the slope. And so the slope increases into that inflection point and then it decreases. And so we get this sharp point here. All right. And it's rather straightforward. We're just going to plot the change in pH over the change in volume versus the volume of titrant added. And the first thing I want to highlight is that you need to make sure this starts at 0 for that volume of titrant instead of just reading that number straight off the burette because that's a common source of error. All right, so first, we'll before I get into it, then I just want to say, what are we going to do with that number? This is classic volumetric analysis. I had some questions on it, so I just want to go over it again with a slightly different view. So you're going to determine the concentrations of the strong and the weak acid. And so we have an acid and we're using the same base for it. And all the steps are the same. So we take what's given, the volume, how much acid used. This should have been pipetted into the flask. And, the volume of the base. This is what you read off the burette. And then lastly, you had to record the volume of the base that you titrated with. And I believe it's stated in the manual should be around 0.1, but you should record off the bottle when you get it. All right, so now using all of this, then you're going to find the concentration of the acid. That's the whole point. What's the concentration? So you have to put these pieces together. And so you take what's known. You take what's known and the volume and concentration, so you can get the number of moles. If you multiply that directly, molarity times volume, that gives us the millimoles of the base. And then this is going to equal the millimoles of the acid here, because this systems that we're using, HCl for the strong acid and acetic acid for the weak acid, they're both monoprotic, all right? And so now we know the millimoles of the acid and we know the volume of the acid, so we can solve for that just dividing those two. All right, before I get into this, so now let's go back to that first derivative plot and let's work to show this. All right, so here, hopefully you're seeing the Excel sheet. And so just again, I like to do all the experiments in a different worksheet. You don't have to, but I find it really easy and I'll show you that. So also just for a life lesson, I always label. I have a first tab, just kind of tell me what to do and so on. So what you want to do is kind of import and have your data 1, data 2, and so on. And what we're going to do is we're going to want to create something like this. All right. And so we could do it with one single column, but it's easy to make a mistake and hard to kind of catch it. Instead, it's easier if we break it up into the individual pieces. All right. And so you have the entry here, and so I would just start with this one. And so I want to have the change in pH over the change in volume, and I want the total volume of titrant. And kind of adjust the axis. And so the first thing is just as you're going along, just what is that change in pH? And then what is the change in volume? And now once I do that, then I can calculate the dividing those out. And so here is kind of the classic thing. So we're wanting to change in pH. So here minus here. And So kind of showing it's going down. So just like in the lecture, we do final minus initial, and that'll make that sign come out. Just matching convention, right? It's increasing, so we want it to increase like that. And so here I can copy and paste this over here, and then just click in there. We'll see how it shifted everything to the right. So I can drag it over and make it to the left and get these numbers. And now that you have these, you can fill these down. If you have a ton of data points, you can use some shortcut, or we can fill down like that using Control D on PC or the Command D on Mac. And now that I have this, then we can easily calculate this change in pH over the change in volume and fill this down. And now we need the total volume. And so since we have the constant here, then what I'll do is just to have it repeat like that is so here's 0, and then now it's equal to this plus this, and it's not really necessary, but you can see by setting it like this, it's like a running total, right? And so each time I'm adding to the volume I had before and increasing. And then what you want to do is you want to check if this is the total volume that you had here. You can do some math down here. It'll easily calculate everything for you. Or you can look at the difference between these two and so on. So this equals that minus that. So one thing, it's so easy to, we can see the similarities, all right? It's so easy to just do a calculation and think it's right. You always want to check one and make sure. And then once you're sure about it, now you have the pieces. So now that we have this, we can come and graph this. And remember a scatter plot, classic kind of problem I forgot, is that the axes are wrong. So sometimes you can shift it around, you can drag them, and sometimes it's a pain. It's just easier if you just copy the cells. And now, see, just easier to do that versus trying to move it, all right? So now that we have this, then you'll want to make it proper. So the zoom things in here. Oh no, that one. Add chart element. I want axis labels, all those kinds of things. All right. So and so now you can just cursor over the top, or you can see it here. Sometimes it's hard to really kind of see, especially something like this. So one of the cool functions is to come over here and use conditional formatting. And then you can use like colors and like that. But I like this one where it kind of highlights and you can see that it's really showing. So we should get the same kind of number that we're getting here to tell us it's the same thing. All right. So that's a first derivative plot. That's all you have to do, kind of break it into the individual steps, and then we can put it together and we get the plot of it. All right. The last thing is, so you would copy and paste this. And well, actually, you're just going to grab pictures. What I would do though is when I paste it, is I would paste special and paste it as a picture. And the thing is here, it's actually still, you can see how it's still selecting the data. It's still matched and stuff like that. So if I copy in the other data, it's going to change it. All right. So now that I have everything done, I need to do, you'll do it for all your trials. It's super easy then. You just want to copy and paste the data into it. And so I'll paste it into here. Everything is all referenced, it's doing things. And so, but there is one problem. See how when we paste, it doesn't go all the way down. So we start, one thing is that if you go further, maybe you don't collect all the data, or you might see that jump in there for the data here. All right. So So you want to make sure you kind of delete off the rows and not have those kinds of defects. You want to pay attention. All right. So now that we have this, then we can copy this and we'll paste it and have our picture. Then we'll have like trial 1, trial 2, so on. All right. So super simple kind of stuff. That's the easy thing for it. So now you have your volumes. We talked about then how you find the concentrations of it and do those calculations. And now what you want to do is find the Ka, all right? So, so how do we do this? Well, there's two ways we can do it. One is that we can look at Ka as our basis, or we can use the Henderson-Hasselbalch. There are, different routes, but very similar kind of ideas. At the heart of it, though, it's kind of reliant on the same steps you would use to calculate Ka. All right. So one single data point, if you wanted to calculate the Ka, how would you do that? All right. And so the big idea is that we know we have to have the concentration of this, we have to have the concentration of this, and in the Henderson-Hasselbalch, we use the approximation that we're using the starting concentration. All right, we won't use that because then we won't see any difference between those values. We're going to want to estimate that for each step of the titration. All right, and so and then lastly, the pH should be the easiest one, right? The pH or the H plus. We're directly measuring that. So these two are the kind of key for calculating this pKa or calculating Ka. All right. In the beginning, before we add any base to it, it's all just the HA, right? And then as we start to add some base here, let's see what happens. So we have some HA, and in the course of the titration, we know the volume and the concentration. So just like we did before, we can find how many millimoles, all right? And then as we start to do a titration here, adding some base in it, now what is that base doing? Now we're taking those millimoles of base and we're doing a neutralization, right? Because that's a strong base. So it's going to decrease this concentration down, and it's going to convert this HA into A minus. All right. And so the neutralization, then we figure out how many millimoles we have. We're going to take it down to 0, take the smallest one before the equivalence point, then we should have excess acid left over, right? And so we're going to take how many millimoles, we'll cancel it off, and we'll be able to find how much HA is left. All right. Does that ring some bell? All right. That's what we need here. Okay. And or here. So how do we get how much HA? So we know the H plus, we know the HA now, and how do we get the A minus? Well, what happens then to the HA is it's converted over to A minus, right? That's what it's showing here. Normally we don't show this in the ICE table because we don't care about it, but that's what we're following here. So you know how much you started with. That was the calculation you just did. We know how much base we're adding. And so we can find how much neutralization occurs. Okay. One last thing is that here, these are both concentration. We can see in this form, the Henderson-Hasselbalch relationship, that we can use millimoles. All right, millimoles on top, millimoles on bottom, or you can convert it back to concentration, just divided by the total volume you had. Because you're going to have both of them divided by the same, it works out to the same thing. All right, so it doesn't look like it over here, but because that H plus is coming directly from the pH, we know its concentration, so that's why it's the same setup as here. We can keep these both in millimoles, and it still works out to allow us to solve for Ka. All right, so that's the hint that I give, and then I'll help you with it in person. But hopefully you you got it. It'll take a little bit of time. It's not an easy one. It's a very advanced kind of lab, but that's it. Okay, the last thing is that you're going to want to calculate for each way along here. So basically, you're going to solve for, instead of pH, you're going to be solving for Ka. Kind of, you're not going to make a graph, although you could, and see a similar type thing. And so it will be the same kind of idea here. It'll plateau. So when you do get those different Kas, we're going to focus on the Kas around here, around this half equivalence point. And you should get in the same kind of number that whenever you approximated before. All right, that's your kind of check for it. All right, that's the lab.